Hello and welcome to a new SWOOD Design tutorial. My name is Jonathan Fernandez, engineer and instructor at Edgeband. And today I will be your SWOOD expert. As you can see in the agenda, we will first define what is a SWOODBox and its interest. And then we will see all the steps to create a SWOODBox from scratch. First, the interest of a SWOODBox is to be able to create custom rules, insert parametric components, drive SOLIDWORKS parts and assemblies, and finally create material removals in the insertion volume of the SWOODBox. In this tutorial, we are going to create a shelf SWOODBox with a single shelf, with an edgeband on the front, shelf positioning from the bottom or centered. We will create 3 holes around the panel. And finally, we will have the possibility to activate or deactivate these railings. First, make sure that the SWOOD Design add-in is activated. When it is activated, we can access the SWOOD Design task pane. And we can see the different libraries. So, we go to the SWOODBox library. We right-click to create a new folder. This folder will be called Tutorials. Right-click on this new folder and create a new SWOODBox that will be called TutoShelf. We right-click on this new SWOODBox and we click on Edit. So we can see that this SWOODBox appears from a SWOODBox template, which is also available when we click on New. Then on the SWOOD tab, we can see here it is the same template. Here we can see that it is a SOLIDWORKS assembly template. There are the 3 basic planes and also additional planes. You can also see that there are 6 sketches that define the 6 sides of the SWOODBox. And there are also offset planes, which we will not use in this tutorial. So, to create a shelf SWOODBox, we will insert a panel. Again, from the SWOOD Design library, we go to the panel library and select the generic panel. With a right click, we can click on Insert Copy. On the left pane appears a new interface specific to the SWOOD panel insertion, and we choose the new panel position insertion mode. Then we need to select the shelf option. We leave the name TutoShelf, and on the graphics area we can see that our panel is already inserted. We can see here by moving the arrows that the panel is not constrained. So, what we are going to do is move the little end arrow to the right plane of the SWOODBox. We must do the same thing with the left plane, the back plane, and last, the front plane. If we click on this red dot, we can remove the mates and start over if we made a mistake. We see that the 4 sides are constrained, but we can still move the shelf up and down. Once the 4 sides are constrained, we can validate the window. On this verification window, all arrows are green. As can be seen in the Feature Manager design tree, the part is not 100% constrained, as can be seen by moving the part with the mouse. So for this, we will go to Mate, expand the assembly here, and select the bottom plane of the SWOODBox and the bottom plane of the part. Select a distance mate as a mate type. For the distance value, we can enter a value of, for example, 200 mm. This value will change afterwards. We can validate we see here that the part is now totally constrained. Because this is a shelf that will be applied in a frame, we will insert an edgeband on the front of the shelf. So, in the SWOOD Design library, Edgeband library, and we insert the edgeband generic EB 2mm. For this, we will drag and drop on the front panel. You can see here the detail of the edgeband. The edgeband function is available here. We are now going to go to the SWOODBox tab. Here there are 3 subtabs. We will stay first in the parameter definition subtab, and we will add a distance parameter. We'll call it bottom space. We change the alias. For the alias, we will use the initials of the parameter's name. Here, BS. We click on Exposed. We will change the initial value of the parameter to 200 mm, for example. To make the link with SOLIDWORKS, we click here on Dimension and click on Selection. Here we will expand the mates and select the distance mate we just created. Once you just have done this, you can see the dimension displayed here in the graphics area. And when you select it, it appears here. Finally, we click on Driving. To check what we just done, we'll go to the Test Mode subtab. Here we can see that the parameter is visible and that we can modify it. So we change his value to 400 mm and rebuild. We can go back to 200 mm. We can also change the SWOODBox overall dimensions, such as increasing the width to 1000 mm, and we see that everything follows. For the centered positioning of the shelf, a diagram here can be seen. In green, we have the SWOODBox height dimension, which will be h. Then we can see the panel thickness here, which is called PT, and the distance parameter we just created, bottom space, which is at the bottom, and in case we have a centered positioning, this distance will be the same at the bottom and at the top. So we can see that the height h is equal to bs plus pt plus bs a second time. So to know bs, it is necessary to write bs is equal to h minus pt, the whole divided by 2. So in order to calculate the value to assign to bs, we need to know the panel thickness, pt. And this thickness can change over time, depending on the material that will be applied to the shelf. For example, if I apply the material generic 10 on the shelf, you can see here that the thickness is equal to 10 mm. We can even check by measuring it. In the same way, when I apply the generic 19 material, we can see now that the thickness is now 19 mm. So this thickness is not fixed in time. So we must be able to know at each moment. So for this, we'll go back to the parameter subtab and create a new distance parameter, which will be the panel thickness. We call the alias PT. We expose it for the moment so that we can check that its value is correct in the test mode. This time, the SOLIDWORKS link won't be a dimension, but it will be a custom property. We click on the assembly icon and then on the part, because we want to get the part thickness custom property. Once the part is selected, we can see all the part's custom properties, and therefore we can choose the thickness. This time we won't click on driving, because we just want to read this value. In the test mode, we will rebuild and see that the panel thickness parameter shows the actual thickness of the panel. You can check this by applying a new material of a different thickness. Once rebuilt, we can see that the panel thickness parameter has been updated. So, we'll use this value of this parameter to position the shelf in a centered way. Now, to be able to choose if we want a free positioning with the bottom space parameter or a centered positioning, we will create a new parameter of Boolean type. We will call this parameter centered shelf. For the alias, we will write CS and we will expose it. We will also click on the initial value, which we will activate by default. So, this time, we are not going to put a SOLIDWORKS link. We will use a script to translate our rule. If we click on this icon, a new window will open, the script window, and we will be able to use the parameters we just created to transcribe the rule we want to apply. It is very important not to delete the first 3 lines at the beginning. We can add several lines for more clarity. We start the formula with if. Here we see the parameter whose value we want to test, true or false. You have to double click on it to write it on the script. When we write if CS, it means if the parameter centered shelf is activated, we write then, and we see that we have an error here. We must write end if so that the script understands that the if condition is over. There is no more mistake. In the middle, we will write what we want to happen when the centered shelf parameter is activated. Bs is equal to the height h minus the thickness of the panel, divided by 2. It's best to put brackets on. When you see that there are no more errors at the bottom, you can close the window, which will save the script automatically. It is necessary to return to the test mode. We can see here that the centered shelf mode is activated, and we will rebuild. We can see that the shelf seems to be well centered in relation to the height of the SWOODBox. So, if we change the height, we see that the shelf remains centered. Here, we can see that the bottom space parameter has a value of 240.5 millimeters. We can check if there is the same dimension at the top of the shelf. There is the same dimension. We have written our script well. Now there is a small problem. It's in case the centered shelf parameter is checked. We can see that we have access to the bottom space parameter, that it seems possible to modify it, which is inconsistent with the centered shelf option. And when we rebuild, the bottom space value comes back to the value calculated by the script. This is because it's the script that takes the advantage over the parameter value entered in the test mode. What is needed is that the bottom space parameter is no longer modifiable if the centered shelf parameter is checked. To do this, we just need to add a new line in our script. So, we are still in the condition if the centered shelf parameter is activated. This time, we will write BS, to which we will add a dot to modify one of the parameter's attributes. The attribute concerned is the read-only, which when set to true will make the parameter visible but not modifiable. Let's check it right now. Let's rebuild a first time, and you can see that it's grayed out. And you can't even select anymore. It works well. Now we will create the side holes that are used to place the cleats. To do this, we will go back to the SOLIDWORKS Feature Manager design tree, and we will open the part. Before that, we need to save. We open the part. We can see here the front of the shelf with its edgeband. And we will focus on the left side. And we will create a sketch on the left plane. So, in this sketch, we will use the bottom edge of the panel as a reference. Click on this edge and press Convert Entities. Then we will select this new line and turn it into a construction line. This is very important for the following. We want to create a vertical construction line. And we are going to draw a first circle on the center of this vertical line. A second circle with the center on the bottom end, and a third circle with the center on the top end. Select the 3 circles and add an equality relation. Then, between the middle circle and the construction line that represents the bottom edge of the panel, we will put a tangency relation. For the diameter of the circles, we will put 5 mm, which correspond to the clit diameter. And finally, as the center distance between the circles, we put 32 mm. A final dimension is missing, that of the horizontal offset between the circles and the panel front. Be careful, here we have to select the sketch origin and not the end of the panel's bottom edge. Here we put 50 mm distance. Well, we'll do the same thing on the other side. We can use the end of this point, because there is no edgeband. And we can create a sketch relation to have circles of the same diameter. Our sketch is now complete. Your sketch should also look like this. We rename the sketch by clicking twice. We are going to call it holes. So, this sketch should be on the left side of the panel. Now we can save the part and we can quit. Now you can see that on the shelf in the SWOODBox there is the sketch we created. Alright, we'll go to the SWOODBox tab and in the middle subtab Machining Definition, develop machining definition and select Drillings driven by sketch. Rename this drilling with the name holes. We click on Sketch, expand the assembly and find the sketch of the part we just created. For the drilling depth, we put 10 mm. And we simply uncheck user points. Alright, now we are going to attribute this machining to one side of the SWOODBox. So it will be the left side. Expand here and select holes. In the test mode, we only have to rebuild. And we can see here that the hole starts from the circles we have created and extend 10 mm to the outside of the SWOODBox. Now we simply hide the part sketch to only see the holes when rebuilding the SWOODBox. We can see what happens when we change the bottom distance. We can see here that the drillings follow the parts because they come from the sketch which depends on the part. Well, now we are going to go back to the Machining Definition subtab, and instead of repeating this task for the opposite side, we just go to the right side, pull down the menu and select Symmetry. It is the symmetry of the left side. We'll go back into test mode and rebuild to see what happens. Here we can see that on the left and on the right, the holes are completely aligned. So here we can see that the panel thickness parameter is still visible. We don't need it, so we'll unexpose it. In the parameters subtab, select the panel thickness parameter and uncheck the exposure. We go back to the test mode and we see here that we have only the two parameters that we decided to expose. Now we are going to see how to activate and deactivate the side drillings. To do this, we need to create a new parameter, Boolean, which we call drilling activation. The alias will be DA. We are going to expose it, and by default, we are going to activate it to have the holes active every time we insert the SWOODBox. We are not going to link to SOLIDWORKS anymore. We'll see how to do it. Here we will go to the machining definition. We are going to see here that there is also a script that defines the rules for the machining. So the script is here. You can click on it. The window looks like the other script's window, but it is a little bit different. We can see here that there are different parameters compared to the other script. The parameter we are interested in is the suppression parameter. This Boolean parameter we given the true value means that it will suppress the drilling. And if it's set to false, this means that the drillings will be visible. So it is a bit of a reverse logic. We have to be a little bit careful. We can see in this side that if we want to activate the drillings, it means that the machining will be active. It also means that the suppression parameter we will set to false. If you want to disable the drillings, it means that machining will be inactive, and also that the suppression parameter will be set to true. So, being able to do that, well, we'll create some new script lines. Once again, we will create a condition with if. We can access the SWOODBox parameter by expanding SWOODBox component. So, we have access to the parameters we created earlier. Here, we can see that we have the parameter that we have just created to activate or deactivate the drillings, DA. When we double click on the DA parameter, which here is written sbc.da, it implies that it's set to true. To remove the error, we write endif to close this condition. And now we will write what should happen when this parameter is active. That means that suppression will be equal to false, as we saw in the slide. It's the opposite logic. And now we must anticipate the opposite case, which is else. Press Tab to offset one step to the right and double click on suppression and write equals true. In this particular script, we have to click on the validation button to save. We will return to the test mode. Here we see the new parameter for activating the drillings. We can rebuild, and if we uncheck it, we can see here that the drillings disappeared. Now we can say that the SWOODBox is finished, and we can save the assembly. So we can now test our SWOODBox in a real case, in a frame for example. So we are going to close it. We'll go to the SWOOD Design library again and go to the frame library. After expanding the simple folder, we will select the with plinth cabinet. Right click and click on edit. We return in the SWOODBox library and we find our brand new SWOODBox. We can simply drag and drop it inside the frame. It is important to check that the blue volume is between all the panels of the box. And we can release the click. Here we can see that our SWOODBox is inserted into the Feature Manager design tree as a new feature. If we look in detail, we can see that the drillings are made on the panel of the frame. For example, if we isolate the left panel, we can see that the holes belong to the part. If we measure the drilling depth, we can see that they are the 10 mm that we have planned. Alright, now let's change the dimension of the frame and stop centering the shelf. We right-click on the SWOODBox feature in the Feature Manager design tree and we click on Edit Feature. So we can see that we have access to our parameters. We uncheck the shelf centering and set a distance value of 200 mm. When we validate the edition pane, we see that everything follows. You can even go here in the SWOOD Design Command Manager tab, Edit Frame. In this interface, we can modify, for example, width, height and depth in the same time. We can see that the SWOODBox follows completely the frame in which it has been inserted. If we display everything, we see that our SWOODBox plans are visible. So we are going to hide them. When we close the frame, we don't want to save it, because otherwise it will save this frame with the SWOODBox into the frame library. We shall edit the SWOODBox again with a right click and then edit. We simply hide all visible plans and sketches. If we rebuild the SWOODBox in the test mode, we can see that the volume of the SWOODBox is still displayed. We can save. Now I'm going to show you one last way to use this SWOODBox to extend its capabilities. We edit again the frame with plinth. We insert the SWOODBox that we have created. We edit the SWOODBox feature in the Feature Manager design tree. We are now going to change the orientation of the SWOODBox. But before that, we disable the drillings. Next, we are going to click on the orange corner at the bottom left to reorient the SWOODBox. This means that the SWOODBox rotates 90 degrees. We validate the edition pane. So now, instead of being a shelf, the SWOODBox becomes a separator. And we can insert again this SWOODBox as a shelf in a new created volume, leaving this time the drillings. We will insert the SWOODBox a second time as a shelf on the other side of the separator. And we will, for example, decide to move the right shelf down. And finally, we will move the left shelf up. We thus obtain a rather sophisticated frame thanks to only one SWOODBox. Thank you for your attention and see you in the next tutorial.